Chapter number 3, current electricity. See, we all are aware about the importance of electricity in our day-to-day life, right? How electricity is important. Now, related to this electricity, we have to carry out some study in this particular chapter. Chapter number 1 and chapter number 2, which we discussed, are known as static electricity. It implies that in those chapters we discuss this thing when the charge is stationary or steady. At that time, how it exerts the force, what is the field of it in the surrounding of it, like that. So all these studies were carried out. But now, if charge is in motion, then it constitutes current. Now, that electric current, first we have to understand here. Okay. See, suppose we have any conductor as shown in this figure. Now, if we imagine any cross section of the conductor and through this particular cross section, suppose in a given time t, total positive amount of charge flowing, that is Q plus, as well as total negative amount of charge flowing, that is Q minus, from left side to right side as shown in this figure. Then the net amount of charge flowing through this cross section in the given time interval t, that we can write Q, that is equal to Q plus minus Q minus. Now, this net amount of charge flowing through any cross section per unit time, that is called electric current. So we can write electric current I, that is equal to Q by T. So we can say electric current I, that is nothing but the net amount of charge flowing through any cross section of the conductor per unit time. So here the SI unit of current, that is ampere. And from this equation we can write ampere, that is equal to coulomb per second. Clear to all of you? Now, if the rate of flow of charge, that is constant one, then steady current is constituted in the conductor. And for that, we can write this equation I, that is Q by T. But if the rate of flow of charge is not constant one, then in that particular case, we have to consider delta Q, the small amount of charge flowing through any cross section in a small time interval delta T. So if delta Q is the amount of charge flowing through any cross section in time interval delta T, then we can give the instantaneous current at that particular instant. That is equal to limit delta T tends to 0 delta Q by delta T. Or we can write that is dq by dt. So instantaneous current, that is the rate of flow of charge at that particular instant. So we can write the equation of current I at any time t, that is equal to dq by dt also. Now from this particular equation, you can calculate the amount of charge flowing through any cross section of the conductor in a given time interval when the conductor is carrying current I ampere. So From this one, we can write dq that is equal to I dt. Now, if we integrate on both the side, then integration of dq that is q, that is equal to integration I dt between the limits t1 to t2. So this particular equation will give you the amount of charge flowing through any cross section of the conductor in time interval t1 to t2. Clear to all of you?